Let's build it together. So here's your chuckle-up distribution. Yeah. In order to get the average of this, we got to know what it is. So we know the payouts. We know the payouts are -$1, $0, $1, $9. Those are the 4 payouts. But they're not equally likely. My God, if they were, we should all be at Vegas. More on that to come in the in-class quiz. Linda, go, please, my friend.
I'm sorry. Are those arbitrary? Like, how do you get the 9 for getting 3 5s?
Who wants to answer that question? Linda asked the question. Are those numbers arbitrary? The -1, the 0, the 1, and the 9. They are most definitely not arbitrary. Tom, what are you thinking?
I said nothing in Vegas is arbitrary.
Nothing in Vegas is arbitrary. Why? Because Vegas needs to keep pumping water into the Bellagio fountain. And keep their lights on all night. And give you free drinks for playing their more expensive games. Nothing's arbitrary. They have those numbers set very... Can you hold that question for about 15 minutes?
I just want to know.
No. The answer, quick answer, no. Not arbitrary at all. A quiz for you guys for next week, should you choose that mission, is to play Vegas and find certain cutoff values for those. Now, I use this distribution for you to extend on your quiz if you want to take it. Oh, it's badass.
So for now, it's not related to the dice or the number.
It's not, no, it's related to the overarching goal, which is what is your average winnings for playing this game? That's a trick question. You guys are so good. You're all meant to be actuaries. All over. Or at least to understand which life insurance policy or which health insurance policy is selected. Oh, more on that later too. Okay, good so far? We now need to know what the probabilities are. Oh, we've been talking for a while. Has this started to even out a little bit?
Is that it?
It's ahead now. Son of a bitch. 31, let's just stop. How about right now? Is that a good place to stop? About 6,000 rolls? That's plenty, right?
Yeah.
31 divided by 6 is 0.0051. 1 over 216 is below that, isn't it? 1 over 216 is below 0.005. I said something like that in 105 class yesterday. They call me Rain Man. 1 out of 100 is 0.01.
Right.
1 out of 200 is therefore half of that, 0.005. So 1 in 216 must be a little bit less than that. This is a little bit more than that. So therefore, we're now a little bit ahead. So you see what happened there? The law of large numbers. We were below. Now we're ahead. At some point during that run, we crossed straight through it. Make sense? Mm-hmm. That's one of those laws from calculus. I forget what the mean value theorem, I believe is what it's called.
But that's still 6,109 rolls.
It is, and if we wanted to get even better, we can let it go. We can let it go off to closer to infinity. As stupid as that statement is to make, closer to infinity.
Yeah.
It sounds like a bad 70s album. Okay, but now we have our probabilities. There's a 57.04% chance. Now this is not exact, right? This is not exact. This is an empirical simulation, Sandra, to come back to what you said. It's an empirical simulation, but it is damn close. When we start talking only about the binomial distribution, which we will do on Thursday, because I won't see you until Thursday, will I? I'll miss you guys for a week. We'll start talking about the binomial on Thursday. Then we'll start figuring out how to calculate these directly. It ends up being, I think it's 125 out of 216 for the exact probability. There we go, you got it, Eric. Good. But that's damn, what is that as a decimal, if you don't mind?
About 57. A little less than that.
I mean, damn close, right? Damn close. I love simulations. Simulations are wonderful. Nate Silver likes them too. Oh, look, we stopped on 2 5s. Hot damn, take the $1. Go buy yourself something nice. What's the chance of 0? About a third, 35.12%. And whatever's left over is 0.0735. And now here we got 0.0051. The only thing that sometimes happens a little bit goofily with these is if you add these up, theoretically, what should they be?
1.
Yes, that's not exactly 1, is it? 6 plus 6, so it's going to end in a 2. So theoretically speaking, this should be 1.000, or 1.0000, I guess. But with simulations, because of rounding error, they're going to be off a little bit sometimes. Don't worry about that. It's not off by much. I'm guessing it's 1.0002 or something like that.
That's right.
Say that again?
Yeah, that's correct.
That's exactly. So we have an extra 2 10,000ths to worry about. That's a rounding error. Don't worry about that. So the sum of those probabilities is approximately close enough to 1 for argument's sake. If you need more precision, just increase the number of decimals that you're showing and call it good. Okay so far? All right. Now we're right at 11 o'clock. Why don't we take our 5? Because you guys look like you want to take a 5. And this door is closed for some reason. That needs to be open and let some fresh air in here. Yes, thank you. Let's take 5, get some water, get some air.
Then I left my water.
Figure out how much we're winning in this game. 0, 1, 225.
I'll survive though. Oh, have a gum, that's what.
No, flop, no. Yes. I'll pretend. If she's the first one, yes.
51 out of 50 minus.
And then you do 51, 0, figure out when she does and when she doesn't. No, you're saying exactly the right thing. When you started talking, my mind went right back to when I was 18 years old, sitting in stack 371 years in Illinois. There was a formula for n prior events before the n plus first. And when you're talking about, can you calculate it, my brain is saying, yep, you sure can, but my God, you don't want to. Because it's a nested conditional probability that stretches pages. So you can do it.
I don't need pages.
Right, and that's my point, is that's why I think you're both saying the same thing, put it like this. You were saying you can do it mathematically, and my brain's saying, yeah, but you want to do it this way. So I'm with you.
Statistical math, and I can't even figure out how
now,
to
this
put my
isn't even a
gum.
very bad calculation. This is a pretty direct calculation at the end of the day. But the program is way, way less direct.
And
I mean, there may be a point.
like all the algorithms.
It's not pseudo correct.
Okay.
It's pseudo But the thing about that is, I don't mind it so much that it's pseudo random because the only thing, it's random enough for our purposes. The only thing that's not random about it is its starting point, for the most part. If I can get a random, remember the things you guys did about a week ago, the snowfall data, and I had you enter your birthday in first.
Just use your
That was
pen.
to seed
I'm
it
gonna use
random.
my pen.
The algorithm will be more random.
Goodness.
If that makes sense. So in other words, a computer-generated algorithm for randomness,
Sure
which is
nobody
very intelligent.
poisoned
All
it.
sense.
Yeah.
Yeah, right. Computer-generated randomness. You can't be random, it's algorithmic. If you can drop it, it's like blindfolding. You blindfold it and drop it out in the jungle and say, start being random.
Would you like one
It
after I
bases
bother
off
you
its
with this?
environment. If it doesn't know what its environment is, it's going to start pretending to be random as best it can. So if you can feed it a certain seed value, you
I
can
don't know if I
kind
did, but I
of
left
let
the water in
it
the
be
car.
less
I'm thinking gum will work.
deterministic. If I had everybody in here take their machines and store 0 in for the random seeder, and everybody presses the random button, you're all going to get the same number. That's exactly the opposite of random, it's predictability. But if I can seed it randomly enough, and here's how I seed my Excel spreadsheets. I just keep using the return. And I stop at, this looks good, grab a stapler and stop. Now it's seeded for next time. As long as you do that, you're covering it enough. For our purposes, military intelligence might not like that. My dad working for a proprietary part he's getting for a patented DuPont won't like that. He's got way more sophisticated methods. But if for purpose of illustration, for you and I talking about sure, but for our purposes of illustrating these probabilities, what we got is plenty there.
I wouldn't know.
That needs to talk.
He was in the movie where,
I mean, I understand what you're saying about for our purposes.
No,
So that's why I'm like,
no, I love what you're saying because you're right, man. You're right. But when you say Anna's got the ace and what's a chance you, I'm thinking way past that. I'm thinking Anna, you, Sandra, Lloyd, and me playing poker, and we now all have 5 cards dealt out. It's way past just Anna when she has.
What else is it?
And you have to nest all those conditions and then become exponentially branched off. And if you can do it, it can be done. I just don't want to, as I just want to myself, doing myself.
yeah,
I'm
they
with you.
they banned
So,
it when they
you are absolutely correct. It's just I wouldn't.
But when you start talking about it, then you think of it, you
I
probably.
guess I'm doing one.
right now waiting for my email to look for 8 hours.
Well, I love the formula in the book. I can visually add an ellipsis. It's one of the few ahead of ellipsis. So saying probability of A given parentheses B given parentheses C given D dot dot dot. I'm like, no, dot dot dot. Finish with the damn formula, and then you realize
But you know that it's not only
infinite.
just.
It's essentially infinite because you keep conditional
Yeah,
done.
So it connected with you. So thinking that here it's like, well, I know something.
Yeah, keep those questions coming, please, okay? Oh, I hope so. I got 4 more weeks and I'm gonna milk every question out of you.
Kind of an.
Oh, yeah. Oh, good.
probability of you being able to do it too, but it's there.
Nice.
It's been down
Just
because-
divided by 216, right?
Yeah.
Right, well, I mean, if I
Oh,
do
good
this
for
The other side, another guy can do.
Careful, careful. It's
He's
not,
been banned from
you're not
all
doing it. You're not
casinos,
doing the one bar, one L2.
and they won't
You gotta run-
they
oh
didn't
my God.
pay out
No,
the
here, watch
last
this.
time we won.
Do one bar stats,
Some people have
but
photographic
telling your
memories
data
and
is
stuff.
in
I mean,
L1, but your frequencies are in L2.
I mean, everybody takes a
that's what I was thinking.
Wait a minute.
There's no way it's positive too. I was like,
Nope, there's no way it's 2.25. That was the ignoring the probabilities, right?
okay, so I can't do 2 bar stats.
2 bar stats is you can, and part of 2 bar stats actually gives you what you're looking for.
They consider
But it's
cheating.
the problem is it's a correlation
Yeah.
of
Always
statistics.
just smart.
Oh,
In other
what
words,
are they
is the data in
They're treating
L1
everyone
related
else.
to the
Like,
data in
they're
L2? And the answer is there's no data in L2. There are simple frequencies.
I mean,
It's
they're
not
cheating
data,
everyone
it's just the
anyway,
currents of data.
so.
Right, you
Cool.
all turn in our
Yeah.
favor.
This is such good questions. It makes me so happy.
It's like,